get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed?
Hello, good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift Expert live stream. I am Johnny Rickard, and I'm joined today by my co-host, Sully, the man, the myth, the legend.
Yeah. I don't know if it's famous or infamous, so I'm going to go with infamous.
Yes, worldwide, prestige worldwide.
Oh, good to see you, Johnny. Good to see you.
Man.
Glad to be
How
here.
Are you?
You know, my wife told me that I'm no longer allowed to say upright and sucking air because it sounds too negative. So I'm doing great. I'm doing good.
Awesome. Well, it's good to see you again. For the eagle-eyed, we have a guest today. His name's Ryan. Ryan, why don't you give us a quick intro?
Sure. Ryan Wallner. Work here at Portworx by Pure Storage. Part of the technical marketing engineering team, and happy to be here. Nice to meet you all. Yeah,
glad to have you. Yeah, so Ryan's team and my team and Sully's team kind of got together, and we've been planning this for a while, and it's finally come to fruition. So it's kind of nice to see a plan go into action and actually happen. So looking forward to today's stream. Like Pure Store's or Portworx, I'm sorry, and Pure Store. It's big time, and it's cool. I think we had another one of your cohorts on here a couple years ago. I can't remember his name, but anyways,
could have been Tim. Maybe.
It might have been Tim. This is what happens when you're 160 episodes deep.
And these red tinted glasses are not on purpose, although I would love for them to be, but I left my regular glasses in the cab on the way back from KubeCon. So you get my Bono glasses, as I say.
You look very stylish, Ryan.
Yeah. I thought it was a flex. I was like, damn, I should have brought my sunglasses. All right, awesome. So before we get started, we're just going to go over a couple top of mind things. And Sully, just so everybody knows, Sully does have to bounce towards the end of the hour. So if he disappears quickly, that's why. So just going into the rest of the schedule. So next week we have Thanksgiving. We could potentially be streaming. At least I'll be streaming with this guest if they confirm and want to do the state. Otherwise, we'll be back on December 3rd with Christian Stark, and we're going to do multi-cluster observability. And then we're also trying to get some more parts of the ACM team onto the stream so we can actually kind of tell some more of the ACM story. Like ACM is they're doing so much work and a lot of awesome stuff within the product, and so it'd just be cool to have them come on the stream and nerd out and brag about it and do all the cool stuff.
Yeah, there's some big changes happening in the next release of ACM, particularly in the UI. So we definitely want to have them. Christian will be talking about observability. We'll probably get him to talk about virtualization as well, because he covers that within the ACM ecosystem. But there's a lot of stuff happening in ACM and in their next release. So we're looking forward to hopefully having them on. Yeah,
we'll do it. We'll just like guilt shame them into just showing up and just try and bribe them. We'll do what we do. So we have a couple top of mind topics. And Ryan, we were kind of talking in the pre-show. If you want to jump in on this one, let me know. Or when you hear something that you want to jump in on, just feel free.
Sure.
So we have first we have the OpenShift Vert is GA on ARO. So Azure, Red Hat, OpenShift. You can now run OpenShift virtualization workloads out there. There's more to come on that. Like I just kind of did like the really quick headline review on this, and so there's an internal thing that they do where they're going over like the benefits and stuff like that. So I'll go and review that, and then I'll try and bring some of that back, and maybe we could even show it off. The Ingress Nginx controller and Ingress Nginx is going end of life. And Ryan, we were talking about this pre-show. I think actual deprecation is in March. The bits will still be available, but like their actual full-on support is deprecating and no longer as of, I think you said March, right?
Yeah, March, and no more sort of CVE protection and all that good stuff that's typically out there. I know a lot of people use the Nginx controller. I mean, we use it internally, right, for a lot of things as well. And so a lot of first people's question is like, is my stuff just going to stop working come March? The answer is no, but you do want to obviously pay attention and probably think about a next step plan beyond that. as far as I've seen, there's no date of when those things will come down, if at all, for the foreseeable future as well.
Gotcha. Yeah, when I first started learning Kubernetes, I actually used the Ingress, the Nginx Ingress controller, and then I found out about Calico, and then I pretty much made the switch and never looked back. But yeah, if I'm ever trying to do anything like really quick, I always throw in the Nginx controller.
I heard that, so reading KubeCon trip reports from various folks, there was, because they announced this at KubeCon, there was a number of folks who came into the Red Hat booth asking about it. So this doesn't affect OpenShift. OpenShift uses HA proxy for ingress, assuming you're not using a partner for, Tigera or Cisco, et cetera, in order to do that. So no effect for OpenShift clusters, but if you are using, another Kubernetes, maybe pay attention.
Yep, awesome. And then the last one for me is ODF 4.20 released, and normally we wouldn't, bring this up, but there's a bug that I guess was identified right at release time where the regional disaster recovery service that's within ODF should not be used in 4.20. They are going to release whenever 4.20.1 gets released, then it'll have the fix for the regional disaster recovery piece. But until then, 4.20.0 ODF, don't use it. It's bad. That's the general consensus. So 4.20.1 will be where the magic happens.
I saw an email about that, and I listened to the product management team chat about it yesterday, but I did not digest all the things that are happening there. So I think if you are an ODF customer, pay attention to the release notes for 4.20.0. It'll walk you through in excruciating detail, or reach out to your account team. They should have all the information there. I had a couple of things. So we talked about this last week, 2 weeks ago, whenever we talked about what's new in OpenShift 4.20. So OpenShift Virtualization 4.20 also went GA. I believe that our blog post that talks about all of the different features there just went live today, if I remember correctly. I'm going to put a link to that here in the chat. So ton of new features, capabilities inside of there. They walk through a number of those. Kind of two big ones in my opinion. So one, cross-cluster live migration is now tech preview. So if you have multiple OpenShift virtualization clusters, you can migrate virtual machines between those. Just keep in mind it is tech preview. And therefore, if you encounter issues, problems, etc., please let us know. It also means probably don't do it in production if you can avoid it. Or at least know what to expect, which is there could be sharp corners. Other things inside of there, I think we talked about this last week. Workload balancing is GA inside of there. So this is the feature that uses PSI or pressure stall information in order to determine when there is CPU steal happening, which is the equivalent of VMware's CPU wait. When that happens, it triggers the descheduler to then move workload away from that node. And then the magic part, if you will, is descheduler will also look at the real CPU utilization of nodes in a cluster and will use soft taints in order to discourage the scheduler from putting VMs onto those nodes. So instead of just randomly moving workload around, and I might end up with a VM that lands on a host that's already, maybe 80, 90% utilized, instead, it encourages that workload to go to the underutilized nodes inside of the cluster. Let's see, I saw there was a question. So is there a home lab method of getting into OpenShift? Yes. So it depends on what you want to use OpenShift for. So if you just want to use OpenShift for like test dev, exploring applications deployed on top of OpenShift, you can use OpenShift Local. Is that what we're calling that thing now? Used to be code ready containers. Yeah, OpenShift Local. So what that does is it uses your laptop, desktop, right, and it creates a virtual machine and puts OpenShift inside of there. So this is really cool. Again, if you're just wanting to deploy some applications inside of there and maybe do some builds, test out pipelines, that type of stuff on your local machine. If you have enough resources in your home lab, and by enough resources I mean I think it's either 6 or 8 cores and I think 16 gigabytes of memory. Yeah. You can install single node OpenShift inside of there. So that'll get you a single node OpenShift cluster. You can do all of the OpenShift things inside of there. It's just single node. If in the future you want to expand it, you can add worker nodes, but you cannot add additional control plane nodes. But that's a great way to get the full OpenShift experience with a minimal footprint. And then last but not least, you can deploy a traditional cluster in all of the ways. Compact cluster is the smallest traditional footprint. I think it's also six CPUs and 16 gigabytes of memory per node, if I remember correctly, Johnny. I'd have to check the docs. It's been a hot minute since I deployed one. So you can deploy that. It can be bare metal or virtual. Both will work. From a subscription perspective, OpenShift comes with a 60-day, 45-day, or 60-day trial license that you can use. Yeah, and then you can also get a free, it's no cost, anybody can go and register, Red Hat developer account. That comes with 16 entitlements for OpenShift, and that's whether it's bare metal or virtual machine based. So developer subscriptions you can use for single user non-production use cases, again, up to 16 nodes. And that can be 16 single node clusters, one 16 node cluster, whatever mix you want to do inside of there. And you can go from there. Developer subscriptions are good for 365 days. After that, you just have to go back into your developer account and renew that subscription, but you wouldn't have to redeploy or otherwise change the subscription used by your cluster there. Oh yeah, I see that you linked the thing there, Johnny. Oh, and then, in the rare instances that your development cluster goes into production, you don't have to redeploy or anything. You just change the subscription associated with it. So, hey, I deployed this 8-node cluster and I was doing developer things with it, but now all of a sudden we accidentally deployed production onto it. Just whenever you get, quote unquote, real subscriptions for OpenShift, you would just switch that over to using those. You wouldn't have to redeploy anything. The last thing that I had to talk about here is Project Hummingbird. So this is, I won't say literally hot off the press because I don't think anybody's actually physically printed it, but this was just released this morning. So Project Hummingbird is our zero CVE, I'll say image library, if you will. So I'm gonna share my window here. So we will share this. Did I see, Donnie, did I see you post the link for this yet?
Nope, no, I'll do it right now.
Okay. So Project Hummingbird to accelerate cloud native development, zero CVE strategies. So again, this is not something I am terribly familiar with. I know that I'm in the process. We had to start the live stream, so I didn't finish sending the message. But I intend to reach out to the team responsible for this and ask them if they are willing to join us on a live stream. So that way we can talk about this, what it means, how it affects both developers and the way that they are, for lack of a better term, building applications using container images, but also what it means to administrators and the platform that is underneath it. So lots of interesting stuff here. If we scroll down a little bit, you can see some highlighted features. So zero CVE status, curated production catalog, an SBOM with every one of those container images, and then full production support for Red Hat. So again, I don't know enough about this side of things to know just how big a deal this is, but I think, anecdotally seeing the chatter inside of Red Hat, there's a lot of excitement around this. So that's all I got for top of mind.
Awesome. Yeah, I had one more that I kind of skipped over because I was moving too fast. But it's the software bug that we saw, or the console bug that we saw in the UI. In 4.20 right now, there's an active bug where if you go to, it's probably just easier if I show you. If you go to the software catalog, let's see, can you see this, Sully? I'm assuming.
Yeah, it's a little small, but I can see it.
Right. So, yeah. So if you just go to the software catalog, there's nothing presented. It's just the list of all the projects until you actually pick a project. So if you and then you have to select default because this is silly. But once you actually identify a project to use, then the actual software catalog is presented and you can use it. It's annoying, but it's not anything that's going to stop you from doing what you need to do. But it's just one of those things that, like, if you're not paying attention, you're like, what the heck is going on? But just know there's an active bug, and hopefully they put a release in. I upgraded to 4.20.3, which is the latest, and it didn't fix it there. But that's just an upgrade. I don't know if maybe there might be a change through like a fresh install on 4.20.3. I'll give it a shot. But just wanted to share that out, that there is a bug. It's known and being worked on.
Yeah, as far as I know, that doesn't affect operator installs.
No,
so
it's just annoying.
yeah, if you choose an operator that gets deployed to all namespaces, that still stays the same, even though you have to select a namespace, a specific project inside of there. So
Awesome. And Hillary, I'm assuming you're talking about Hummingbird.
I would assume the same.
Awesome. But yeah, that's it for me. That's it for the. I was trying to actually have a top of mind list this time since we've been kind of just showing up and winging it. So
Winging it works sometimes, yeah.
dude, I've been living by it, man. Like I'm trying to be better though. So cool. Well, Ryan, you want to go ahead and kick it off?
Sure. Yeah. So, what I'm here to share with everybody is really what we've been up to in the world of OpenShift and storage, which these days focuses a lot on virtual machines, right? OpenShift virtualization. So, we're getting many questions talking with, folks at KubeCon. We were there last week. That was last week, right? Feels like a whirlwind. All the way to customers that are sort of looking for a new landing place for their virtual machine footprint, and they're worried about things like what's the operational experience look like from vSphere to the OpenShift UI to how I migrate from my existing infrastructure over to OpenShift virtualization, and how do I get things like, does storage vMotion and DRS exist in the world of OpenShift virtualization? So a lot of these questions and problems is sort of what our teams at Pure and Portworx have been sort of focusing on. And if you're not familiar with what Portworx is or who Pure Storage is, right? We're first of all a partner with the Red Hat folks. We've been doing a lot of integrated work with the OpenShift platform, and we provide storage to workloads like virtual machines and containers. Specifically, Portworx is a software-defined storage layer that acts as a global storage pool that gets deployed directly onto your OpenShift cluster. So when you go to the catalog in OpenShift and you search Portworx Enterprise, you can install our operator, define what a storage cluster looks like. And depending on your architecture, that could mean many things, right? In the enterprise world, typically you have some investment in an existing SAN or something like that. You can tell Portworx to kind of build on top of that and utilize your existing investment there. Or you can just use, attached disks that are on your OpenShift worker nodes, and we'll kind of pool them all together. And I know that's sort of a really fast way to deep dive into what Portworx is, but we're kind of talking a little bit more about the individual things that are related to virtual machines in today's live stream. So we can definitely dig in or send some. I'll forward some links of where you can learn more about Portworx in general, if that's of interest.
So just a quick question: Is Portworx like is it on-prem only, or do you have like a hosted service? Like, is it something like you can go into like an AWS, say, hey, I want to integrate with Portworx, and then it spins up like a Portworx storage cluster that you can then hook your cluster up to? Is it like
So
that?
no, that's a really great question. So Portworx works both on-prem or in the cloud, right?
Okay.
Because it's completely software-defined, delivered as a container image. Whether you're on Amazon or Azure or on-prem on your own hardware, we install into the OpenShift cluster the same way. The benefit of this is that whether you're using EBS volumes or some other on-prem SAN or direct attached storage or NVMEs or whatever it may be on-prem to some other cloud storage, Portworx works the same way, right? It gets installed. We consume that underlying block device, essentially. So it's an EBS block device or a Google persistent disk or just a LUN that's been attached and available with LS block. We consume that ourselves and actually create a virtual storage pool that's global across your cluster. So you get the same APIs interface and actually whether you're running in cloud or on-prem. I think we have for that cloud, but with OpenShift, or the operator on the cluster itself.
And Ryan, correct me if I'm wrong. I think Portworx is the only storage vendor that supports 2-node with Arbiter today, right?
Yeah, so this is definitely one of the things that is exciting, especially for the 420 release, where 2-node Arbiter sort of is a GA, I believe.
Is GA.
Yeah, so Portworx itself works in that 2-node Arbiter configuration, and I'm just going to bring up a quick slide here that shows this. Mind you, let me just grab the right slide here. So 2-node Arbiter with Portworx, right? The whole idea is this is sort of an edge deployment, right? 2-node Arbiter, even without Portworx, is obviously something that is important for the edge. Whether you're retail or industrial, you may only have some closet space or a few small rooms. So things like minimizing the amount of hardware you need, or minimizing the amount of actual CPU resources, or even the cost of a solution in these smaller closets or spaces to run real workloads that have some sort of high availability to them. The 2-node Arbiter architecture is really interesting in the sense that Portworx typically always starts with 3 nodes, right? We always say for enterprise deployments, small to larger, you need 3 for quorum, and then you scale up from there. The 2-node Arbiter architecture is obviously, it's in the name, 2 nodes, and there's an Arbiter node on top of that. So the way Portworx works in this scenario is the actual storage nodes that Portworx usually deploys into OpenShift deploy onto these two OpenShift worker nodes that are also the masters. And then we have a small process that runs on the OpenShift Arbiter node that helps maintain quorum. And that thing can be, I think, up to 200 milliseconds away, for storage metadata operations. We do have that sort of requirement, but you can really minimize the amount of sort of hardware and cost that goes into these things, but still get a lot of the benefits that Portworx brings to an OpenShift cluster for a software-defined storage, like high availability or live migration, or things like data movement and snapshots and all those things. So you can, have third parties come in and do maintenance on these things, or have the ability for one of these nodes to have an issue and you're still online and things like that. So really interesting for those use cases at the edge.
Yeah, this is where, me on the BU side, we hear 2-node requests frequently and often, specifically because of edge use cases.
Sure.
There's a ton of folks who want to deploy, in their, I'm going to say robo, but I don't know how many remote office deployments we have anymore. It's a lot of retail and, commercial and stuff like that. I will say, so from an OpenShift perspective, I believe it is developer preview, but it might be tech preview with 4.20 is 2-node with failover, TNF, which is the version of 2-node that uses, I kind of never remember what RHEL HA is called.
Is that the fencing one, or is that different than
Yeah.
that? Yeah. Okay.
Pacemaker.
Pacemaker. Yeah. I don't know why I can never remember pacemaker. I always think heartbeat, pacemaker, heartbeat. But I can never remember pacemaker. So I'd have to go back and look at the What's New presentation to confirm that. But we are working on having a true 2-node architecture that doesn't have an arbiter node. So I don't know what that means from a storage perspective yet, but.
Yeah, right. I mean, right now, we need that third node for the quorum piece. I'll leave those conversations for futures of we can support something like that.
And thank you, Michael, for pointing that out to me. One of these days, I need to have a sticky on my monitor, and it tells me it reminds me. It's one of those things I can never remember for some reason.
Yeah, I forgot I had this example here, but this is actually what a storage cluster YAML file sort of looks like in the Portworx space. But when you're using it on the 2-node Arbiter configuration, this might be of interest to people. You can provide some things like tell Portworx you can run on the master node, right? Typically, you're not running the workloads and the master nodes, but when you're consolidating, you kind of have to instruct it to do that. And then you also have to say, hey, if we're on the arbiter node, don't use any storage. We don't have any use for any storage there. We're not putting workloads there. We don't want to put workloads there. And then obviously for us, we need to say, tolerate some of the roles that we typically don't schedule on, right? Which is master nodes, control plane nodes, arbiter nodes. And really the nice part about this is Portworx is set up in such a way that, this is how we install onto an OpenShift cluster. You provide a storage cluster YAML file. And for arbiter, we just kind of tweak some things. It's really flexible, and that's in that case. If folks like to see YAML, I know it's a love-hate thing for me with YAML over the years.
Yeah, I think it is for a lot of people. It's having a GUI is nice for getting started, but then once you get to any sort of scale, doing it through the API or the CLI makes things a lot easier. Anyways, no, that's really cool. I'm excited to see the 2-node stuff come to fruition, and it's great that y'all are not only the first but the only storage provider that supports 2-node right now. So.
Yeah, we had several conversations at KubeCon. I don't know about you either, but this was something that, folks would come up to us and say, here's my use case. I used to run it this way. I'm looking for this. And then we would say, hey, have you seen the 420 release in 2-node arbiter? And they're like, no, show me more, right? So I know this is going to probably be of interest to a lot more folks. And it was really good to have those conversations at KubeCon with various folks. So I know there's a lot of interest there.
And I think, I'll point out the other important part is all of the Portworx features continue to work with that 2-node setup. So if you're doing replication, if you're doing backup, if you're doing all of that other stuff, you can continue to protect those sites, whether it's container-based or virtual machine-based workload out there.
Yeah, exactly. And the other part of this is, Pure has something called Pure One as well, which is sort of like a multi-cloud way view into your Portworx clusters. And if you have a lot of edge locations, say at every retail store you have, this can actually give you a view into all those edge locations. We have some AI built into that too, so you can say like, hey, which one of my edge clusters is the most utilized? Like, is there any problems? And it'll kind of go through your 400 or 5,000 edge locations, if that's how many you have, and kind of spit back some answers to you without you having to do the legwork. So a lot of cool stuff there from us.
Nice.
That's really cool. Hillary asked a question here. If running on a control plane node, is there a guide on other configuration needed to ensure that Portworx is a good neighbor to the mission critical workloads?
Yeah, so I guess Portworx itself is sort of a workload and provides storage to any other workloads, right? I guess it depends on what you mean by other neighbor mission critical workloads, but I'm assuming those are also ones that would be running on these control and worker nodes that are combined. A big thing to consider there is Portworx itself uses some CPU and memory, right, to run. It's pretty minimal, so we can still really help minimize the overall sort of CPU and memory you need, but take into consideration of what workloads are running on there, and design it in a way that you make sure you have the overhead to run your mission critical workloads that may use storage, and other mission critical workloads that do use storage that Portworx might be giving access to the underlying PVCs and PVs for. Now, I will say that 2-node arbiter is the way we show it is 3 nodes, or 3 nodes with one being an arbiter. But there's really no reason if you had more rack space or even another VM where you couldn't just have a standalone worker, right, as a third node, for instance.
Worker nodes aren't supported with 2-node yet.
There you go. Yeah.
I interpreted Hillary's question as a more generic, like any compact or not even compact, any schedulable or any cluster with a schedulable, that's a hard word to say, control plane has this, I'm going to say, issue around the control plane is a critical workload, right? API server, etcd,
Yep. Okay.
storage, right? Portworx, these are critical workloads that need resources, guaranteed resources, because they're going to have a ripple effect that affects everything if they're impacted. So I look at it as like, one, how do I either keep other things from affecting them, which usually the way that we do that is through things like request limits and pod priority, and how do we keep them from affecting other things depending on the case. I don't remember like the footprint of Portworx, and being a storage system, typically there's caching involved, that consumes memory and stuff like that. I don't know if that's something that can be limited or controlled, or if
Yeah, so Portworx itself, because it's a storage process, runs with some privileges on the actual nodes themselves. So it's considered a critical, piece of part of the infrastructure. That being said, there are individual parameters that you can provide to that storage cluster YAML that I was showing before to kind of dictate how what the performance and how much CPU and memory it's allowed to use, right? So we see this typically when we're these adjusted when we're like thinking about how to run things at larger scales. We give more host CPU and memory to the Portworx process to kind of scale to the larger numbers. But it will work similarly in the sense that those are defined for Portworx, and those are going to be sort of consumed at that level.
I seem to recall, don't we have a joint sizing guide?
We do have a
Right.
joint sizing guide.
Yeah.
Yeah.
So
somewhere.
my thing is always like, anytime you have a cluster with a schedulable control plane, sizing is important. It's even more important when it's a compact cluster, so 3 nodes,
Yep.
3 full nodes. It's critical when it's 2 node and single node, although single node doesn't count in this instance, because like we want to have an understanding of what is the footprint of the infrastructure pieces, control plane, storage, etc. And then we want to size those nodes appropriately for the workload that's on top of it. So absolutely, we can dig up that link for the sizing guide. I think there's also a best practices guide for Portworx with OpenShift and OpenShift virtualization, if I remember correctly.
Yeah, and we do have a scheduler component that works along with the existing scheduler that OpenShift has, meaning we're aware of the storage pieces, but we respect other things like how much CPU and memory is available for this process. Yes, it's using storage, so we want to put it near the local replica, but we only do that if there's enough available as well.
Yeah. Now I'm trying to remember what that's called. Something
Stork.
bird related.
Yeah,
Stork.
storage orchestrator for Kubernetes for long.
I knew it was something bird related. There's been a couple of questions that have come in here in chat. Questions, comments. Michael, so 2 node fencing is going to be really important for disconnected. Yep, absolutely. I think even 2 node with arbiter is also important for disconnected, but you just have to be cognizant of like, what does that actually mean? Like, if I'm disconnected, do I have 2 nodes in the data center and 1 across the campus? Do I have 2 nodes in the data center and 1 in a closet, or different rows? Like, you just have to be cognizant of your failure domains. But yeah, absolutely. And to your point, Michael, like, yeah, even if you're deploying connected, I've got 2 nodes in my data center, and then the arbiter is in, say, AWS or Azure or something like that. Ryan, you said that Portworx has 200 millisecond latency requirements
for the arbiter. Yeah.
Yeah, I think OpenShift it's 500 milliseconds, but that comes with caveats for etcd, because remember, etcd latency is what determines API scalability. So every bit of extra latency that we have on etcd is that many fewer operations that the API server can do, which could potentially limit what you're trying to do in the cluster. But yeah, to Michael's point, like, yeah, you lose network connectivity at that point. You lose WAN connectivity. Now your cluster is down to 2 nodes, which means another node being lost puts the cluster in a read-only state until something comes back. So Fame asks, with Nginx ingress being retired, is there any backward compatibility support? Jonny was the one who responded to that in chat. So OpenShift doesn't use Nginx. It uses HA proxy for ingress. So there is no impact to OpenShift there. No need to worry about backwards compatibility with anything. Now I ran out of chat that I had actually read before, so now I have to. Is there anything that I missed here, Jonny? I see you're responding to things. So.
You got it. Michael also said that to limit the resources for Portworx, you could also use an application I/O control to limit that. So. But other than that, yeah, you covered everything.
Yep. Yeah, I see you also responded about if you were using Nginx with OpenShift, because OpenShift, I think it was Docker. Was Docker the ones who originally coined the batteries included but replaceable? I want to say I remember them talking about that at DockerCon
Sounds right. It feels right.
a
Yeah.
while ago. But OpenShift is the same way, right? We ship out of the box the default OpenShift ingress is or HA proxy, but we don't prevent you from swapping things out or deploying a second and choosing to use that.
Yeah.
So Ryan, I don't want to steer the conversation or anything, but I know you and I and my team and your team have interacted quite a bit as a result of specifically virtualization, which you called out before. And I want to, I know we've done this before, but I want to again publicly call out just how phenomenal Portworx has been in supporting virtualization and VMs running inside of OpenShift. Like, y'all have always been, like, if not the first, like the second of our storage partners to support all of the different features and functionality. And I can't express how great that is and how thankful I am for all of your support. So thank you.
Of course.
Yeah. So are there? I see something. And I see 1 second. We'll circle back to me.
I was trying to wait. I was just gonna let this moment.
I was going to transition and start asking about virtual, like what the topic of or the title of today, which is Portworx and virtualization. So maybe we want to stop now. Is MetaLB going to replace HA proxy? So they are complementary. They won't replace each other. So MetaLB, so HA proxy is what's used if you're using a route / ingress. OpenShift, if you create an ingress object, translates it into a route. So that's where that comes in. MetaLB is used when you create a service of type load balancer inside of the cluster and you have MetaLB there. So MetaLB can do some other cool things, right? It can work with BGP in order to advertise up, as well as use BGP to load balance across the endpoints there. But it is not going to replace HA proxy as the ingress. I am curious, and Jonny, we've talked about this before. Gateway API is a thing upstream and quickly becoming a thing, and I think it's available as developer preview, if I remember correctly. Maybe not. Gateway API is on the roadmap if it's not available yet. So Gateway API, I think, is going to be interesting and what that means. I believe that OpenShift is going to be using the Istio Gateway API implementation. Note that Istio is also service mesh, but these two are not the same thing. They are related, but they are not the same thing. So I'm curious how that's going to affect things long term. We'll have to corner our network PM team and see if we can get them to come on and talk about it.
Sounds like a good topic for a future show too.
That's the one, like, whenever I think of like ingress being replaced or like HA proxy being replaced, it's Gateway API. It seems like that's the way that the whole community is going, right? It just seems like that's going to be the way, but I haven't seen anything concrete yet.
I know on the retirement blog post, they also suggest, right, and recommend Gateway API, right? Because there's still a lot of effort going into that and support and all that.
Yep. Yeah. And so it has issues. It here, I'm assuming referring to OpenShift ingress, which is HA proxy based routes. Correct. So routes only work with port 80, port 443 HTTP traffic. If you want to do something on a different port, you would either use a host port node port service type to open up a port on the nodes, or you would use MetaLB. And the difference there is MetaLB has an IP block assigned to it. And so effectively, it generates or it creates an IP on one of the hosts, and all that traffic comes to that host, or in the case of BGP, it gets spread across them. But it comes to that host, and I can use any port inside of there, and it doesn't consume a node port or host port, which there are a limited number of those, as well as they have other ramifications of using them.
It basically does the same thing like the old TCP load balancer function, right? That's pretty much what MetaLB does when you have like a non-HTTP HTTPS. It translates it as like a TCP port and then just does its thing, right?
Yeah. So it's my understanding of Metal LB in layer 2 mode is effectively it creates the listener IP address, or so Metal LB has pods running on each one of the nodes that it's eligible to run on, and it creates a listener IP address on one of those nodes, and basically all the traffic comes to that node on whatever port has been defined for that IP address, and then on the back end it distributes it across whatever pods are running inside of there.
Okay.
In layer 3 mode, BGP mode, it communicates with the upstream switch or router and basically says, hey, BGP, this workload is balanced across these 3 nodes, right? Whatever nodes have the listener. And then it relies on the upstream device to split traffic across those nodes inside of there.
Okay, awesome.
But not everybody has BGP, and the layer 2 implementation is, I think the biggest difference is one, there's a little bit of failover time with layer 2 mode, right? If the node that has that IP address goes down for whatever reason, it has to transition that IP address over. I think it uses keep alive D, but I might not be remembering that correctly. I think there's a different mechanism now that I think about it a little bit. But similar, it takes a couple of seconds for the IP to move, whereas the BGP method doesn't. The other thing is it would be limited to the ingress throughput of a single node, right? The layer 3 BGP method, it truly distributes it across.
He gone.
Sully had enough. He's like, you know what? I'm done with these questions. I'm done answering questions.
Oh, there we
I
go.
don't know what happened. It blipped. Like literally, I'm rambling. I'm running my mouth, and y'all freeze, and I'm like, gosh, is it that boring? And then it goes, oops, connection lost, reconnecting, and now I'm back. As a tangent, I do have to drop in 6 minutes. So,
it cut
anyways,
you
yeah, if we were bored, Sully, I'd be like,
Johnny's over like, no, this is nope, Sully, it's too much. And like hit the button on the back end that the proverbial hook off the stage.
Exit stage, right?
Yeah. Thank you, Alan. I appreciate the question. Hopefully everything that I was saying there, I don't know how much was lost, but long story short, Metal LB and HA proxy, they're both going to remain independent. What I don't know is how Gateway API is going to affect those things. So Ryan, let's talk about virtual machines with Portworx.
Let's do it. Yeah, so some of the other things that we get asked a lot, and I mentioned this a little bit in the beginning, was, do I have similar features, right, coming from my vSphere clusters, like storage vMotion or DRS and things like that, and this is something that the Portworx team has been working on quite a lot, which is, we're building on top of the existing storage migration technology in OpenShift already today, which allows you to go from like storage class to storage class, and we're enhancing this a bit because we have control sort of over that data plane layer once we're installed in the OpenShift cluster. And this lets you do really interesting things like migrate from different data stores that we provide across your OpenShift cluster. And maybe they're backed by different block storage, right? So we talked about cloud-based deployments and on-prem based deployments. This could be a third-party array, could be one from Pure Storage, but they give different IO, profiles, and you might want some existing on certain backends and things like that. So this is sort of the storage vMotion aspect or similarity when you're coming from that world to the OpenShift virtualization mechanism, and you do this, sort of without disruption, and we integrate this seamlessly. And if we have time, we have a nice integration at the UI level that we've been sort of adding more and more to in the plugin layer. Portworx has had sort of an integration of like, you can see the whole storage cluster, but now we're integrated into the VM workflows, where if you're looking at a specific VM, you can go to another tab and get exactly, where all your replicas are, what backend storage pool or data store it's a part of, and things like that. So storage migration is a big piece of this. This also bleeds into the rebalancing piece, which is more of the DRS component, which is you you may want your backend storage to to automatically choose the best placement for the type of workload, meaning based on things like latency and IOPS and things like that. You may want a mechanism that allows the VM to move across those data stores to make sure that we're balanced across the different storage components that you have available in OpenShift, but also that it's serving your workload properly with the right IO and performance and things like that. So these are two topics that come up quite often that we dig into as well.
So correct me if I'm wrong, Portworx has a temporal awareness of the data, if I remember correctly. So we talked about Stork a minute ago. So I feel like I'm speaking for you, so please correct me if I'm wrong. So let's say I have, like we see on the screen here, I have 3 nodes that are hosting my Portworx cluster, and I have my data protection set to basically two copies of the data. So only 2 of those nodes are going to have my data. Stork will, by default, influence the scheduler to put the virtual machine, really any pod, but the virtual machine, onto a node that has that data local in order to reduce latency and increase performance and all those other things. But I think Portworx will also work behind the scenes and determine, like, hey, this other node, has, I'm going to say, it's not very busy, so maybe we want to move some replicas over there, or move the primary, the active disk over to this other node, so that way it can balance out those resources.
Yeah, and that's the storage rebalancing piece, right? Portworx has always had the ability to have multiple pools on each node, and those pools can have a different footprint, right? So maybe it's backed by NVMEs, maybe it's backed by spinning disk or a remote storage mechanism to provide those block storage. They all provide very different characteristics for your workload. So not only does Stork provide data locality for scheduling, meaning we sort of interrupt that or kind of get in the middle of the scheduling decision for storage-based workloads. So anything that has a PVC that uses a Portworx volume, we kind of look at the whole picture, right? Yes, we integrate with traditional, ways of looking at what utilization is best happening where, but then we also look at the replicas. And that may be based on, if you have, like you said, 2 or 3 replicas, we might put it in the best failure domain with the best performance on the best place. The rebalancing piece is a little newer in the sense that typically that still happened across like to like, sort of like homogeneous storage pools on each back node. Now we can kind of go cross storage pools, meaning change of performance as well.
And that's the part that uses, you were saying, builds on top of OpenShift virtualization and its ability to do storage live migration.
Exactly, and this is a big change for Portworx as well, because in the past we've worked in a way that uses storage pools on individual nodes, and those are pretty static. Meaning, once a pool is built on a node, that pool is it basically abstracts local storage, and we provide virtual volumes out of it. But that pool doesn't move away from that node, right? The replica exists on different nodes, which means the workload can move to a different node, and your data is still available, and we serve the IO from that new replica. But this picture with rebalancing, we also have the ability, because we have, especially with virtual machine workloads, we don't always necessarily find our end users wanting to have that potential performance hit of extra replicas, right? They've invested a lot of potential money into a backend SAN, for instance, and we build on top of that. They're coming from a world that VMs sort of build on top of a one-to-one mapping or a volume, and they still get the best, a data store. And so we've created this cube data store, which basically takes that takes the idea of what Portworx has always been good at and unifies it for both VMs and containers. And there's a better architecture here, but if I remember where it is, So this is what I was explaining before. Portworx has always had storage pools, but we're introducing a new pool with Kube Data Store. So this Kube Data Store is an abstraction of all the pools in a cluster, that global storage pool I talked about. Static pools are the way Portworx always worked. So it's a term that we're introducing, but it's just consider it the way that Portworx has always worked. Those pools on each individual node built on top of whatever block device is available are static. But VMs often want the best performance. Maybe it's a fiber channel backed block device that's supporting a pool, and they want one replica. They want one replica, but they also, for the best performance, but they also want high availability, and that's hard to do to keep workloads highly available with one replica, as we know. So Kube Data Store basically introduces the concept of static pools and dynamic pools. And a dynamic pool will take the shared versus the typical shared nothing architecture, meaning, your existing investment, this could be a flash array, for instance, as I'm depicting here, but it could be a third-party array. And those LUNs are attached to your worker nodes as they normally are, except Portworx builds a dynamic pool on top of that. And really all that means, to simplify a lot of the words that I've been saying, is that dynamic pool can move across your nodes. And how this is different from a traditional CSI moving from node to node like a LUN rescan is that we kind of like pre-map and pre-attach these connections, and then we kind of like move them around and let them float, meaning we can have one replica, but if an entire node goes down, with one replica we can actually move that pool, which contains multiple virtual volumes still, for one or more VMs, but we're not doing an entire one-to-one mapping, right? So like traditionally, like with CSI in general, we often find, like, if you have, say, 500 VMs and each one of them have a few volumes, 1,500 VMs, if you do a rolling upgrade, that basically translates to like 11,000 operations. This still limits it while giving the high availability.
Well, you're decoupling the storage from the node,
right?
And so in my mind, I think the way I would describe this is, traditionally, it's Red Hat doesn't call it hyperconverged, but I'm going to call it hyperconverged, right? Of my Portworx data node uses the local storage for that server in order to create a shared pool across multiple nodes. With this now, I'm no longer using truly local storage. Instead, it's volumes coming off of a backing storage device. And if this node goes away, I simply reattach that backing LUN to a different node, and it becomes the new storage node inside of the cluster. And so therefore, I can quickly recover those volumes, assuming they're replica one versus multiple replicas. I can quickly recover those nodes and reshare out those volumes or reconnect those volumes for those whatever workload was running on side of there.
Yeah, and it's not entirely that abstract compared to how CSI works with any third party, other than those are one-to-one mappings, right? One PV to one LUN attachment, which can often lead to a lot of churn and congestion when you do things like rolling upgrades or maintenance or even live migrations, right? This still gives you the abstraction Portworx has always done at that virtual volume layer, but also kind of pre-maps so that you really do have minimal LUN, iSCSI rescans or fiber channel reconnections and those kind of things.
Yeah, I think that volume count issue is also important, not only because I say this with no malice, but like not every storage device can support the volume count needed for something like a virtual machine deployment, where each one of my VMs can have 2, 3, 4 volumes, right? I have a main operating system disk that gets installed. If I'm using a VTPM, that's another volume that gets created there. Any snapshots or additional volumes associated with it, so on and so forth. So by using this Kube Data Store concept, I can now take advantage of the performance and data resiliency features of my enterprise storage array without having to worry about the volume count issues associated with OpenShift and OpenShift virtualization, or Kubernetes OpenShift virtualization.
Exactly. Yeah, it's still virtualized at the layer. And Kube Data Store for us, it's supposed to feel familiar for people coming from, an existing data store technology in the VMware space. We're trying to map those things really well to a combination of OpenShift virtualization, as partnering with you guys, and what we're providing with this data store, our Kube data store layer as well.
And I think importantly, it also means that things like snapshot and clones happen at the Portworx layer. So Portworx's features and capabilities there, with regard to capacity consumed, performance impact, all that type of stuff, remain.
Exactly. So all the benefits on top of like even multiple OpenShift clusters, when you're doing DR between them, Portworx disaster recovery still works at that virtual layer, right? There's things that we can do on the back end as well, especially with the Pure family of products. But if you're using us mostly as an abstraction, even with heterogeneous backends to support different data stores, we can provide that sort of similar mechanism, that sort of single plane that reacts and works the same way across your clusters as well.
Very cool. Well, I do have to drop. My apologies.
Yes, we left you in the dust.
No. This is super interesting to me, and like it solves, one of the problems that we hear about regularly with regard to OpenShift virtualization, which is, the volume scale, just the sheer number of volumes is hard for some storage devices to handle, and that's okay, right? That's expected. Enterprise storage arrays, like many of them were not architected for a high volume count. They're architected for high performance, high capacity, and especially high availability.
Mm-hmm.
And when we have technologies that can build on top of that and basically utilize all of those features and capabilities that are baked into literally 5 decades of enterprise storage, and then solve the problems of the last 10 years with regard to Kubernetes and volume count, like that's amazing to me. Like that's great news. But all right, I really do have to go. Thanks, y'all.
Yeah.
Thanks, Sully. Yeah.
Later, man.
I know we only have a few minutes left, but the other thing is we've worked closely with OpenShift, like I said, on the plugin side of it. So all this is this is going to be visible within the OpenShift UI. And then we've done a lot of integrations with the migration toolkit for virtualization, which allows you to migrate, VMs from existing infrastructure onto OpenShift virtualization. And we've done that with various offload technologies that you can kind of enhance the, how fast you can migrate your virtual machines. Without having to rely on moving everything over the network, we can do things with things like Xcopy on our backends and our arrays and things like that. So really, really fun, really tight integration with Red Hat.
Nice. Yeah, it's crazy to see how far all this stuff has come, man. Like it's just OpenShift virtualization in general, OpenShift itself, it's one of my favorite things to talk about is how how it's evolved, to just this what it is now. It used to be felt like a bunch of rogue projects and stuff like that, and now it's crazy. I don't know if there are any Black Friday certification coupons or not, to be honest.
Already in shopping mode, are we?
Yeah.
I like it.
Yeah, I have no idea. Yeah, so I don't know if there's anything else, Ryan, that you wanted to show or talk about, or we are at the top of the hour, but I could go over a little bit if you wanted to show something off.
No worries. I guess the one thing I didn't show just now that I was talking about was the MTV integration, right? So this is built on, and let me share my screen for those who do want to see this because that's important. So for those who are familiar with Migration Toolkit for virtualization, built on top of Forklift, right? And OpenShift is obviously all integrated there. And what Portworx has done is basically take the MTV and Forklift toolkit and allow us to run the migration of the actual data copy within the FlashArray controller. So if you're coming from like VMFS or vVols or those kind of things on your existing ESXi clusters, you can do this translation without having to typically do the data copy over the network using the existing BDDK SDK. And we can do this sort of at the controller level, which at the end of the day gets you migrated faster. And I won't do the demo for time, but what we've seen is like huge disk migrations go from hours to minutes, right, with Xcopy. And so this is, I think, is in Forklift 295, so that's already out. I think some of the vVol integration is going to be in 2910 or 2911. Don't hold me to any of those, but it's somewhere in that vicinity. But really what this enables some of our, big end users to do is, they have, hundreds of thousands of VMs.
Yeah.
And if they did it with some of the tools that are out there, they work, but it takes a long time, right?
Mhm.
And I'd probably be able to grow my beard 10 times longer by the time it was done. But yeah, this is a big improvement, and obviously built on top of existing Forklift open source technologies and integrated with OpenShift. So this all happens, in sort of the OpenShift UI once you connect what's your VM network in ESXi and what's your VM network and pod network translation and all that goodness. We could probably have an entire show just on MTV. It's a really cool stuff.
That's awesome. Yeah, we did a stream on MTV like a year ago, like a year and a half, something like that, a long time ago. It'd be good to do something like that again, because I feel like, especially with how big OpenShift virtualization has gotten over the last year and a half, like it just kind of makes sense to probably revisit that. Yeah, that's awesome, man. Like, so when you're plugging, do you just get another? I'm assuming you just get another tab in the accordion that says Portworx or Pure Store, and then you dive into that and you do it.
Yeah, we dive into that. We, when you set up Forklift integration with us, I think you just replace one container, or just to use our container image, and then you say to use the offload. And then that will basically, when you create the migration plan, which is the CRD name, you create that migration plan, then it'll use that offload, and it'll tell you it's moving the data volume and it's moving the disk, and if it's successful. The other thing is we also saw a big increase in the amount of successes, right? So obviously you want to obviously do migrations over a particular network, and you don't want to congest certain things. There's other things that go into mind here, just like live migrations. But what we saw is with these really big disks for certain VMs is that sometimes they'd fail, right, for various reasons, because maybe they're just they're trying to move for hours. But with some of the offload features, is because it's moving quicker and copying sort of not over the network, maybe a network interruption doesn't get in the way, and so we saw a lot more success of migrations as well. Like, some failures happen in these scenarios, but we did, that was a pleasant surprise to kind of increase the sort of reliability, I'll call it, of it as well.
Yeah, because you can imagine, right? A lot of those long running processes over time, they eventually stale out. Like, if you've done any large copying thing, then you've run into this before. Like, it's no secret that you're gonna have a problem. That's pretty awesome. So, like, I'm trying to think of like the right way of asking this. Do you have like a was it 30% better, or is it just like anecdotally better?
I'm sure there's a percentage out there somewhere. It's I'm gonna call it a lot better. I'd have to do the math on it, but and it also really depends on like what you're migrating, right? So if you're migrating a couple small disks, right, you're gonna have less of a change. But if you have large backing disks or root disks for your VMs, and those VMs are ancient and been around and no one wants to touch them, those could take hours, right? Yeah, down to minutes, right? And it's consistent with the Xcopy change as well.
And I think that's the big thing right there, right? It's consistent, right? It doesn't always have to be perfect, but as long as that experience is consistent, I think that's where there's more value there's more value in that, I think, where it's like, okay, that's why we love Chick-fil-A. They're consistent. It's going to be good every time you go, right?
Speaking of Chick-fil-A, right? This was, and we talked about TNA and Edge. I had spoken with one of their architects a long time ago, and they have a great Edge story to tell, and it's literally a closet with like a couple pucks. No, who knows? Maybe TNA will make its way over to Chick-fil-A, and then we'll all
That'd be
be
awesome.
very happy.
Yes, free chicken sandwiches would be amazing. I live in England. We don't have Chick-fil-A. Well, I lied. They just opened a Chick-fil-A in Leeds, but it's too far away, and there's
Oh,
too many
okay.
people.
I didn't
so,
know that they were all the way over there. Yeah, they had. I think when we spoke a few years ago, it was like 5,000 edge deployments, and it's
Yeah.
probably bigger now.
Yeah. I remember hearing something about that a few years ago. I think they have like 3 nodes per 3. Either I think you said pucks, right? 3 nugs or whatever, like per store. So yeah, and just in San Antonio where I moved from, there's like a billion of those stores there. So you can only imagine how many endpoints they have.
Yeah, exactly.
Yeah. Man. Awesome. Well, hey, I really appreciate you coming on. Like I know it's we had a pretty decent runway getting to this point, but thank you for coming on. Like really
Yeah, of
enjoyed
course.
it. If you ever want to come back, just let us know. Yeah, if you got there's some new feature you're rolling out or something awesome you want to show off or whatever, just let us know. We'd love to have you back.
Sure. Yeah, no, it was fun. Obviously, the space is moving fast. I feel like with every OpenShift release, there's always new stuff. So I'm sure we'll be back on and chatting about it more.
Yeah, man, that's gonna be awesome. Hopefully something cool drops from Portworx around Summit time, and or even KubeCon EU time, and we can
Oh
have you
yeah,
guys
back in
on.
Atlanta. Here we
That'd be
come.
cool. So for all the viewers, again, just to recap on the schedule, next week is Thanksgiving. There's a I would say a slim possibility that we stream, but most likely not. We're gonna if all goes the way it is right now, we'll be back on the 3rd, and then we will try and close out the year with a couple more solid ACM topics, hopefully. But then we'll kick off the new year, and we'll try and get these PMs and engineers back on the stream and talk about all the things that we want to talk about. Hey Ryan, again, thank you very much, man. I really do appreciate your time, and it's never easy to get online and do these things, but you crushed it, man. So glad to have you, and you're always welcome back.
Happy to be here, Johnny. Thanks for having me on.
Awesome. All right, we'll see you guys later. And so tomorrow, GitOps Guide to the Galaxy is back. So if you want to watch that, it's I don't know what time anymore because I live in England, so my time zones are all messed up. But it's 7 p.m. London time, so whatever that is in the rest of the world. Awesome. Anyways, catch you guys next week. Bye.